probably heard the term the Internet of Things, or IoT. And yeah, it sounds a little like sci-fi, but it's already all around us. It's why your watch talks to your phone, and your phone can talk to your house. But how does this invisible network of connected stuff actually work without just becoming total digital chaos? Today, we're going to pull back the curtain and look at the blueprint that makes it all possible. Just look at this. You've got mobile payments, smart cameras, data analytics. It's this whole ecosystem of devices all communicating. Each one has its own specific job, right? But the real question, the big one, is how do you get all these different parts, which are often made by totally different companies, to actually cooperate and create something useful? And that really is the key. When you imagine billions of devices all chattering at once, it's so easy to picture just a wall of noise. But it's not. A well-designed IoT system is way more like a symphony orchestra. Every single instrument plays its part, they all follow the same score, and together they create something coherent and powerful. So let's get a quick definition on the table. At its heart, the IoT is just a network of physical objects. We're not talking about just computers and phones anymore. We're talking about everyday things. Thermostats, cars, factory machines that are embedded with sensors and software, letting them connect and swap data over the internet. Okay, but this brings us right back to the central challenge. Think about it for a second. One company makes your smart thermostat, another one makes your smart light bulb, and a completely different one makes the app on your phone. How on earth do they all speak the same language? How do they coordinate? This is the problem of interoperability, and it's honestly the biggest hurdle to building a truly connected world. The answer? They need a shared blueprint. It's just like our orchestra. It needs a musical score that every single musician can read. It doesn't matter if they play the violin or the tuba. The IoT needs a common framework that every device and every developer can understand. And that framework is what we call an architectural reference model. And here it is. This is the IoT functional model. Let's break this down because it looks like a lot, but it's pretty simple. Think of it as the standard way to organize all the different jobs inside any IoT system, from the tiniest little sensor all the way up to the app on your phone. This right here is our musical score. So let's start at the very bottom with layer 1, the device. In our orchestra, these are the actual instruments. They're the sensors that hear the world, measuring temperature, motion, light. And they're also the actuators that play a note, like a smart lock turning or a light switching on. This layer is the direct link to our physical reality. Okay, so an instrument plays a note. Now, how does that sound actually get to the audience? Well, that's layer 2, communication. This layer is all about the networks. We're talking Wi-Fi, Bluetooth, 5G, you name it. Its only job is to reliably get the data from those devices up to the rest of the system. Once that data arrives, it lands in layer 3, the IoT service layer. This is where the raw notes, so to speak, get processed. So imagine a raw temperature reading comes in. This layer is what cleans it up, maybe tags it with a time and location, and makes sure it's in a standard format. It basically gets the data ready so the rest of the system can actually understand and use it. But what's the whole point of this entire blueprint? Well, it serves one huge function: to create a digital version of the physical world. It is the bridge between atoms and bits, between what's real and what's data. And this is a perfect example of what I mean. On the left, you have a physical car in a physical parking spot, plain and simple. Through an IoT system, that real-world event is translated into the digital world as a simple but really powerful piece of data. Parking spot number 16 is occupied. That, right there, is the magic of IoT in action. So where does that data point, parking spot number 16 is occupied, actually live? It lives in layer 4, the virtual entity. This layer is the thing in the Internet of Things. It's the object's digital twin, a virtual copy. The system isn't really interacting with the actual car. It's interacting with this virtual version of parking spot number 16. And finally, we get to the top, layer 5, the application. This is the part we, the users, actually see and interact with. It's the app on your phone showing available parking spots, or the big digital sign at the garage entrance. This is the final performance, where all that data from the lower layers is turned into something genuinely useful. Now, you've probably noticed those 2 columns running up the side. These aren't separate steps. Think of them as constant guardians. Management is like the conductor of our orchestra, overseeing the whole system, making sure every device is online and everything's running smoothly. And security, well, security is the foundation of trust. It has to be present at every single layer to protect the data and ensure privacy. Without these two, the whole symphony just falls apart. So let's put it all together with our smart parking lot. A car pulls in, the device, a sensor, detects it. The communication layer sends a tiny signal, the IoT service layer processes that signal, updating the virtual entity for parking spot #16 from empty to occupied. And boom, the application layer changes the main sign at the entrance. A complete, seamless symphony, all the way from a single car to a single piece of useful information. So why is having a blueprint like this so incredibly important? Well, because it solves the biggest problems in IoT. It makes sure a sensor from company A can talk to a system from company B. It lets developers build new things way faster because they have a common framework, and it gives us the structure we need to actually secure the system and to scale it up, from one parking garage to an entire smart city. And that really brings us to the ultimate takeaway here. The future of the Internet of Things isn't just about making more clever devices. It's about creating and agreeing on standards. A reference model like this creates a common language, and that common language is what will unlock the true potential of our connected world. So, we have the score for the symphony, we have a blueprint for connecting pretty much anything to a global network in a way that's structured, secure, and can grow to a massive scale. The only question left is, what incredible new music are we going to compose with it? What will we choose to build?